Hey everyone, today we are going to be looking at factoring trinomials when a does not equal 1. For those of you that are in Mrs. Hanson's class, that's me, we briefly talked about this before spring break. So we're going to go back through and review how to factor a trinomial when a does not equal 1. All right, so we are going to take a look at this first example. We're asked to factor 2y squared minus 3y minus 2. And so to explain what I mean by a is not equal to 1, right? If we have this trinomial right here, the coefficients 2y squared minus 3y minus 2. We have three different coefficients. The leading term here is called A. The middle term is called B, and the constant is C. Now, this is true if the trinomial is written in standard form, meaning in standard form, the highest power goes first, the next highest power goes, and then the constant goes at the end, right? We talked about degree of polynomials before, and so the highest degree term goes first, and then the powers go down or descend in order. So if we're looking at what the value of a, b, and c are in this particular trinomial, we have a equals 2, which clearly a is not equal to 1. B equals -3, and C equals -2. And what we're going to do is we are going to factor this trinomial, and we use the same process as we do factoring when a is equal to 1. And so what we'll do is make our little table, and if I multiply a and c, since a is positive 2 and c is -2, I get a product of -4. And b is equal to -3. So I'm going to make a list of all the numbers that multiply to be -4, all the pairs that multiply to be -4. So I'm going to start with -1 and +4. I could do +1 and -4, 2 and -2. Right? And so I'm looking for the pair that actually adds up to be -3. Right? Of these pairs, which pair adds up to be -3? So if I look at this, the pair that adds up to be -3, -1 and 4 is +3, 1 and -4 is -3. So this is the ordered pair, or not ordered pair, this is the pair of factors that I am going to use to break apart my middle term. So what I'm going to do, currently we have a trinomial because there's 3 terms here. This magic pair that we have here of 1 and -4, we are going to use that to break apart the middle term. So we have 2y squared, and instead of -3y, we're going to rewrite that as a +1y and -4y. And then leave the constant at the end. So the first term and the last term go unchanged. These pairs that we came up with in our table are used to break apart the middle term and rewrite it as 1y minus 4y. Now what that does for us is it allows us to group, right? We're going to factor by grouping here, right? And so we have even groups of 2 terms and 2 terms, which I can then organize in my box, right? So I'm going to scroll up here a little bit. And I'm going to organize this in our box. And I'm going to put the first 2 terms in the top row and the second 2 terms in the bottom row. And then what I'm going to do is I'm going to factor out a GCF. So I'm going to factor out from the top row, what is my greatest common factor? So if you're looking at 2y squared and 1y, my greatest common factor there is just 1y. right? Remember, you could draw a factor tree for 2y squared and break that apart into 2 and y squared and then y and y. And you could also draw a factor tree for 1y and break that apart to 1 and y. So we have our prime factors of each term. And the 2 could be broken up into 2 and 1. So you have 1 and y that those two terms have in common. Now, if you're looking at the bottom row, right, across here horizontally, negative 4y and negative 2, well, both terms are negative, so I'll factor out a negative. And if I think about 4 and 2, the greatest common factor of 4 and 2 is 2. And if I factor vertically, right, if I factor vertically in the first column, that is going to be a 2, right? 2 and negative 4 have a common factor of 2. And the common factor between y squared and y is just 1y. So we have 2y as our greatest common factor. And if I look at 1y and negative 2, the greatest common factor of 1y and negative 2 is just a positive 1. Now, you can make sure that you did this correctly by multiplying first row times first column. If I multiply first row, row 1, by column 1, that should give me the product 2y squared. So if I multiply 2y times 1y, I get 2y squared. If I multiply row 1 times column 2, that should give me the entry in row 1, column 2. So 1y times 1 does give me 1y. And again, likely on the bottom row, so row 2 had a common factor of negative 2, so if I multiply negative 2 times 2y, that should give me the entry in row 2, column 1. And lastly, row 2 times column 2, negative 2 times 1 gives me negative 2. So my factorization, if I look at the bottom of my, here, the greatest common factor is 2y plus 1. And along the side here is 1y minus 2. So remember, we can always factor this, we can always multiply to check our answer. So this is my factorization. If I want to check my answer, I can go ahead and check by foiling, using the FOIL method of multiplication, because that's really what we're doing, is we're multiplying those two binomials. If I take 2y plus 1 and 1y minus 2, and I FOIL that out, we can go first. So 2y times 1y is 2y squared. Outer, 2y times negative 2 is negative 4y. My inner product, 1 times 1y, is positive 1y. And then my last terms are positive 1 times negative 2, which is negative 2. Now, if I combine these middle terms, 2y squared, negative 4y plus y is negative 3y, and then we end up with a minus 2 on the end. And what do you know? That is what the polynomial was that we started out with. That's the trinomial we started with. So we know that this is the correct factorization. 3. All right, we're going to take another look here. I made a typo. This is supposed to be an x right here, not a y. But what we're looking at is factoring 8x squared plus 2x minus 3. So if we follow the same process as we did before, right, first of all, let's label A, B, and C. So A is 8, B is 2, C is negative 3. So I'm going to write that down. A is 8, B is 2, C is negative 3. And if I multiply A times C is going to be a negative 24. And B is a positive 2. So again, I'm looking to list all the numbers that multiply to be negative 24, and my magic pair needs to add up to 2. So If I start with -1 and 24, I could do +1 and -24, 2 and -12, -2 and +12, 3 and -8, -3 and +8, -4 and 6, and +4 and -6. Now, if you look at these and I add them together, -1 plus 24 is a +23. So that's not the correct pair because I want to add up to be 2. 1 and -24 is -23. 2 and -12 is -10. -2 and 12 is 10. 3 and -8 is -5. 8 and -3 is +5. -4 and 6 is +2. 4 and -6 is -2. So here I have my magic pair, -4 and 6. Now, if you can come up with this pair without having to list all the possible factors, I'm fine with that. If you know in your head what two numbers multiply to be -24 and add to be 2, you don't have to go through this entire process of listing out all the factors. I just did that so people would understand my process if they do struggle with finding a pair that adds up to be +2. So moving forward, we are going to use the -4 and +6 here to break apart our middle term. So we started with 8x squared plus 2x minus 3. We are going to break apart that middle term, and instead of 2x, we're going to have minus 4x plus 6x. Realize that -4x plus 6x is still the same thing as 2x. And then I'm going to carry down the -3. So the first term and the last term are left alone. We don't do anything with those. So now we went from 3 terms, a trinomial, right? 3 terms meaning trinomial, to 4 terms. And what that allows us to do is to group or use our box method. So if I scroll up here a little bit and if I create my box, my 4 squares, right? And I record in the box 8x squared minus 4x, 6x, and minus 3. I'm going to go ahead and factor horizontally. So if I look at 8x squared, -4x, 6x, and minus 3. So 8x squared minus 4x, if I look at those two terms together, side by side, the common factor would be 4x. Now again, if you need help figuring out what the GCF is, go ahead and write out your factor trees. 8 and x squared, 4 and 2, 2 and 2. My prime factorization, x and x is x squared. -4x would be -4 and x. -4 would split up into -1 and 4, and then the 4 splits up into 2 and 2. Okay, so if you look at the tree, right, what do they have in common? They have a 2 in common, they have another 2 in common, and they have an x in common. So if you look what I crossed off 2 times 2 times x, which we know is 4x. That's why I got 4x as my common factor. Now if we look at 6x minus 3, if I break apart 6x, that's 6 and x and 3 and 2. And if you look at -3, that breaks up into -1 and 3. What do they have in common? Both trees have a 3 in common. So my common factor is 3. All right, so I'll write that in green. My common factor is 3. If we're looking at 8x squared and 6x, if I look at 8x squared and 6x, my common factor is going to be a 2x. If you look at the factor tree for 6x and 8x squared, they would have a 2 in common, and they would have an x in common. And then lastly, looking at -4x and -3, because both terms are negative, we are going to indeed factor a negative out. The only number that is in common with negative 4 is a positive, or is a negative 1 here, right? So 4 and 3 have a common factor of 1. They're both divisible by 1. And if I move up a little bit here, slide this up, and I look at, now that I've factored my GCF from each column and each row, I look at what I have. On bottom, I have 2x minus 1. And along the side, I have 4x plus 3. And that is my factorization for that trinomial that we started with. Now, again, you could check your work. I'm not asking you to check every single time, but you could use the FOIL method, right? And say first, outer, inner, last. So my first is 4x times 2x. That's 8x squared. My outer is 2x times 3, which is 6x. My inside is negative 1 times 4x, which is negative 4x. And then last would be negative 1 times positive 3, which is a negative 3. So we end up with 8x squared. If we combine like terms, 6x minus 4x is positive 2x, and we have a minus 3 at the end, which is the trinomial that we began with. So that way we know our factorization is correct. All right, we're going to go through one last example together. This time we have 6s squared minus s minus 5, right? And so if we look at our a, b, and c values, our a value is 6, our b value is a negative 1, and our c is a negative 5, right? This is negative s, so we have a negative 1 in front of that s, and then c is negative 5. So if I make my table of values and I multiply a and c, a times c gives me a negative 30. A b is negative 1. So I'm looking for all the numbers that multiply to be negative 30, and I'm looking for a magic pair that adds up to be negative 1. So if I write out my factors of negative 30, I could go negative 1 and 30, positive 1 and negative 30, 2 and negative 15, negative 2 and 15, 3 and negative 10, negative 3 and positive 10, 5 and negative 6, 6 and negative 5. Right? If you look at the pair, the magic pair, I could go through and add all these together. This is 29, negative 29, negative 13, 13, negative 7, 7, negative 1, positive 1. So it looks like positive 5 and negative 6 are the magic pair because when I add them, I get negative 1, and when I multiply them, I get negative 30. So that means I'm going to take and break apart, I'm going to break apart this negative s, and instead of negative s, I'm going to rewrite that as minus 6s plus 5s. Now, sometimes students will ask, does it matter what order the 5 and the 6 go in? No, because addition is commutative. I could switch these two around and say 5s minus 6s. A negative 6s plus 5s is negative 1. A positive 5s minus 6s is also a negative 1. So it does not matter the order that you put them in. So you could reverse the order between the negative 6 and the positive 5. So here we have our 4 terms now, and so I'm going to be able to go ahead and create our box, right? I'm going to create our big old box here. 4 squares, 4 terms, 4 squares. The first 2 are going to go on the top row, and the next 2 are going to go in the bottom row. 5s minus 5. If I do my greatest common factor, right, 6s squared and negative 6s, I'm going to factor out a 6 and an s. Right, again, if you want to do your factor tree, 6s squared is 6 and s squared. 6 breaks up into 2 and 3. S squared breaks up into s and s. If you have negative 6s, I get negative 6 in s. And then this would break up into negative 1 and 6, 2 and 3. Here's my factorization. If you look at the tree, the prime factors of each tree, what do they have in common? They have a 2 and a 3 in common and an s in common. So 2 times 3 times s is actually 6s, which is why I have 6s there as my greatest common factor. A 5s and a negative 5 are going to have a 5 in common. A 6s squared and a 5s are only going to have an s in common, or you could factor out one s if you wanted to. And then negative 6s and negative 5 are going to, because it's both terms are negative, I'll factor out a negative, right? So negative 6s and negative 5 are going to have a negative 1 as their common factor. Again, feel free to draw out your factor trees. You don't have to do that, but if you're struggling with the GCF, it really helps to draw out your factor trees. And so if we look at what our factorization is, on the bottom we have an s minus 1, and along the side we have a 6s, and this is a positive 5. Right? That 5 was positive, so we'll say our factorization is s minus 1, 6s plus 5. Now you, just like I said, because we're multiplying here, just like I said before with the addition, when we were breaking apart that middle term, multiplication is also commutative. So 6s plus 5 times s minus 1 is also the correct response or correct answer, right? So you can go ahead and check your response if you wanted to FOIL. Just quickly, if we wanted to check, we could FOIL and say s times 6s is 6s squared, s times 5 is 5s, negative 1 times 6s is negative 6s, and negative 1 times 5 is negative 5. And if I combine like terms, 5s negative 6s is negative 1s minus 5, and that is the trinomial we began with. So that means we did FOIL and we factored correctly. All right, so this is your turn to show us your understanding of this learning target. On your own, I would like you to factor the trinomials below and submit your answer on Edpuzzle. So the two trinomials you have are 2h squared minus 5h minus 3 and 4n squared plus 16n plus 15. So go ahead and factor and then submit your answers on Edpuzzle.